Let's take a look at this example. It says, using the definition of the slope of a tangent, determine the slope of the tangent to the curve y equals to x squared minus 4x at the point determined by x equals to 3. So what we want to do here is we want to algebraically determine the slope of the tangent. The first thing that I'm going to do is, because I don't like working with y equals to, I'm going to change y equals to instead to f of x equals 2. So I'm just going to make a tiny let statement here. I'm just going to say let y equals to f of x. That way I can keep it in function notation. So after doing that, the first step that I'm going to do is I'm going to figure out the point that's associated with x equals to 3. So I'm going to plug in 3 into my function. And if I simplify, I'm going to get negative 3. So that means the point that's associated with x equals to 3 is 3 and negative 3. The second step that you're going to do now, remember, when we're talking about the slope of a tangent, we want a line that, not a line, we want a point that's super close to x equals to 3 without being x equals to 3. That's where that h comes in. It acts as a buffer for us, so we have two different points. So what we're looking at now is f of 3 plus h. And so what we're going to do is we're going to plug in 3 plus h in everywhere that we see x. So I'm going to do 3 plus h squared and then minus 4 times 3 plus h. If I simplify that, I'm going to get h squared plus 6h plus 9 minus 12 and then minus 4h. What you're going to do here is you're going to simplify everything. So collect all your like terms. So I'm going to get h squared plus 2h and then minus 3. Chances are when you're dealing with f of a plus h, you are going to get some expression that has h in it still. That's normal. So now that I've gotten my second, what I would call quote unquote point, which is dealing with 3 plus h and then h squared plus 2h minus 3, I can now use the equation to help me figure out the slope of my tangent. So the slope of my tangent is going to be the limit as h approaches 0. And remember, we're looking at f of 3 plus h minus f of 3 over h. And so I'm going to plug everything in. That's why I did all of that kind of expanding and simplifying stuff on the side, so it makes it a little bit easier for us to solve the limit. So I'm going to end up having h squared plus 2h minus 3, and then minus negative 3. Be aware of your signs here, all over h. Now I'm going to simplify. Don't go in right away and start plugging in h is equal to 0. Simplify first. See if you can cancel some things out. So right away I notice, the negative 3, and then this will become positive 3 cancel. And then I'm left with the limit as h approaches 0 for h squared plus 2h over h. Now I notice, wait, I can factor out an h from the top and the bottom. So I'm going to do just that now. So if I do that, I'm going to be left with the following. And then I notice, I can cancel out the h's. And then I'm just left with the following now. I'm just going to move my screen slightly a little bit over. So I'm going to get the limit as h approaches 0 for h plus 2. At this point, I'm going to do a direct substitution. I'm going to sub in h equals to 0 now. So I'm going to get 0 plus 2, and then that's going to leave me with 2. So the slope of the tangent for the curve y equals to x squared minus 4x at the point determined by x equals to 3 is 2. That's how we figure out the slope of the tangent. Now let's take a look at the second part of this example, example 3b. So example 3b now asks you, figure out the equation of the tangent for us. So right away, you already know the slope of your tangent. We found it out in the first part. The slope of your tangent is 2. You also know the point of tangency. So in order to figure out the equation of the tangent, you need the point of tangency. And that point is 3 and negative 3. And now you're kind of equipped with the idea that you need to create the equation of a line. Remember, you can use point-slope form to help you figure out the equation of your line a lot easier because you have slope and a point on your line. So in this particular case, point-slope form, remember, was y minus y1 equals to m times x minus x1. I'm just going to label my point x1 and y1, and I'm going to plug everything in now. Remember to be mindful of your signs. So this is what I've got, and then I'm just going to simplify. So I've got y plus 3 equals to 2x minus 6. And if I simplify, get y on its own, I'm going to get y equals to 2x minus 9. So therefore, the tangent line to the curve y equals to x squared minus 4x at x equals to 3 is y equals to 2x minus 9. That is the most accurate line in terms of the tangent at that curve at that particular x value. So rather than drawing it by hand, now we know an algebraic way to figure out the slope of the tangent at a particular point, and then at the same time also figuring out the equation for the tangent line at that specific point as well. Let's take a look at another example. In this example, it says determine the slope of the tangent to the rational function f of x equals to 3x plus 6 over x at x equals to 1. So in this case, we're just figuring out the slope of the tangent. I've already got it in function notation, so I don't need to talk about a let statement. So we're going to start off with our first step. We're going to start off by figuring out what f of 1 is. So I'm going to plug it into my function, and that's going to leave me with 9. So that point is 1 and 9. The second step, we're going to generate that second point so we can actually find slope. So the second point, remember, is going to be 1 plus h. And then I'm going to get 3 times 1 plus h plus 6 over 1 plus h. If I simplify this a little bit, expand and simplify my numerator, collect like terms, I'm going to end up getting 3h plus 9 over 1 plus h. So your second point is really going to be 1 plus h and then 3h plus 9 over 1 plus h. So I've gotten my quote-unquote, what I would say, 2 points to help me figure out the slope of my tangent now. So the slope of my tangent is going to equal to the limit as h approaches 0. And we're looking at f of 1 plus h minus f of 1 all over h. And like I said, we've already done the simplifying on the side, so we can just do kind of a straight plug in what we got. So f of 1 plus h was 3h plus 9 over 1 plus h. F of 1 was 9, so I'm going to do minus 9 all over h. Now at this step, you've got a fraction happening in the numerator of a fraction. We want to simplify that first. So what we're going to do is we're going to try to get everything with a common denominator in our numerator first. So by doing that, this is what you're going to end up getting. You're going to get 3h plus 9 over 1 plus h. And then it's going to be minus 9 times 1 plus h over 1 plus h all over h. Okay, so remember, adding fractions, you need to have a common denominator. So what I'm doing now is I'm going to simplify my numerator. If I simplify my numerator, I'm going to end up getting the following. I'm going to end up getting 3h plus 9 minus 9 minus 9h, and then I'm going to allow to bring that denominator from the numerator underneath, so I have this now. So I'm just going to cancel out some things, and then I'm left with the limit as h approaches 0 for negative 6h over h times 1 plus h. Right away I notice, hey, I can cancel some things out. I can cancel h and h, and then I'm left with the limit as h approaches 0 for negative 6 over 1 plus h. At this point, I can do a direct substitution. So that's going to be negative 6 over 1 plus 0, which is just going to give me negative 6. So the slope of the tangent to the rational function f of x equals to 3x plus 6 over x at x equals to 1 is negative 6. In this particular case, we had to simplify our numerator a little bit first before continuing our journey on canceling things out. Let's take a look at example 5. So for example 5, it's asking the same thing. It says determine the slope of the tangent to f of x equals to root x at x equals to 9. So again, it's already in function notation, so I don't have to worry about a let statement. The first step that we're going to do is we're going to figure out the function at x equals to 9. So that's going to give me the square root of 9, which is just going to give me 3. So I know that my 1 point is 9 and 3. And then the next part is to figure out my point relative to 9 plus h, right? We want to create that second point for our purposes here. So I'm going to have f of 9 plus h, and that's just going to give me square root 9 plus h. Unfortunately, that doesn't simplify, so it's going to be 9 plus h, and then the square root 9 plus h. So now that I've gotten my 2 points to help me out, I'm going to start off my third step, which is going to be figuring out my tangent, or the slope of my tangent, my apologies. So the slope of my tangent line, remember, is the limit as h approaches 0 of f of 9 minus f of 9 over h. So, like I said, we did all that simplifying on the side, so we're going to use that to our advantage now. So that's going to be square root 9 plus h minus 3, and then all over h. Now, chances are this is not the first time you've seen something like this, right? When we were solving limits before, you saw things with radicals, and you figured if you plug 0 in at this point, you're going to get indeterminate form. So we've got to think about all the techniques that we know how to do to help us evaluate this limit. This is why we spent so much time on limits. So I realize here that I can rationalize. I'm going to rationalize my numerator. So I'm going to multiply the top and the bottom by the conjugate of my numerator here. If I do that, I do the limit as h approaches 0, and then I'm going to get 9 plus h minus 9 over h times root 9 plus h plus 3. Simplifying, I'm going to get the limit as h approaches 0. I'm going to be left with h at the top, and then h at the bottom, and then root 9 plus h plus 3. Right away, I notice that, hey, I can cancel out my h's. If I do that, then I'm left with the limit as h approaches 0 for 1 over root 9 plus h, and then plus 3. At this point, I notice, hey, if I plug in h equals to 0, it's not going to cause us any problems. So I'm going to plug in exactly that. So I'm going to get 9 plus 0, and then plus 3, and that's going to give me 1 over 6. So the slope of the tangent to f of x equals to square root x at x equals to 9 is 1 over 6. So in today's lesson, we learned about how to figure out the slope of the tangent algebraically if you were given the function and the point of tangency. So either I can give you the physical point, like ordered pair, or I could tell you the x value that it's going to be at the point of tangency. We also talked about how to create the equation of the tangent. As long as you know the slope of the tangent and you know the point of tangency, you can create your equation of your tangent line. So as a quick review, remember, in order to figure out the slope of your tangent at some point, you need to figure out first what f of x is, or what f at that point is. Then you got to figure out the second point, which is f at x plus h. You've always got to remember that plus h at the back, so it mimics a second point for you. And then you're going to use the limit as h approaches 0 for f of x plus h minus f of x over h, and you're going to use all of those limit solving strategies that we worked on and we developed to help you evaluate the limit to determine the slope of the tangent. Remember, we will not ask you to figure out the tangent by hand. We will always ask you to figure it out algebraically, because algebraically is the more accurate way.